Welcome to News at National. I'm your host, Rick Czar. No matter what type of product or solution you're designing, more and more engineers are seeing a need to use some sort of sensor in their designs. The use of sensors is critical in applications such as industrial control, medical devices, high-end consumer applications, HVAC, and more. And whether the sensors measure pressure, temperature, weight, optical power, or any other physical effect, it's often a challenge for design engineers to develop the signal path that is optimal for the sensor's performance. It can take a lot of valuable development time to match a sensor's characteristics to an op-amp's DC performance and to an analog to digital converter's resolution and accuracy. Whether you're well experienced in sensor signal path development or just starting out, now there's a great online tool available from National Semiconductor that can solve the challenges you face in these projects. It's the WEBENCH Sensor Designer tool, and it's the industry's first sensor signal path design tool that enables engineers to quickly move their sensor system design from concept to simulation and on to prototyping. The WEBENCH Sensor Designer tool significantly reduces your design time and costs by configuring a complete signal path solution with just a few keystrokes. Let me show you how it works. Here we see the main Sensor Designer page. For this example, let's say you're designing a device to measure the level of a fluid in a tank. So the sensor type we will select is the bridge pressure sensor. Now you see a new page offering you a choice among a list of sensors. You can select your sensor from the list or a sensor closest to your requirements and adjust the parameters to fit your needs. Once you've selected a sensor, then you can click the Create Design button. The WEBENCH Sensor Design tool then displays a performance summary which includes a schematic and total error versus resolution for your sensor signal path design. By clicking on the schematic, you can see that the tool matches the industry's leading sensors with National's power-wise energy-efficient op-amps and 8, 10, 12, 14, and 16-bit ADCs. Among the products that National is offering are the LMP7731 low-noise precision amplifier and the ADC161S626 16-bit differential input ADC. The tool also allows you to quickly make performance-to-price trade-offs, and you can easily optimize a design for your particular sensor by choosing a different op-amp or ADC, or by modifying your system values. Let me show you an example of how National Semiconductor completes the sensor signal path in a sample application. What we've developed here is a demonstration of a liquid level control application using a gauge pressure sensor. Pressure sensors are grouped into three categories: gauge, differential, or absolute configuration. They are used in various applications like altimeters, flow measurement in industrial and process control, and patient monitoring. On the bench here, we have a tall cylinder of fluid. This could represent fluid storage of some sort, say a tank of sulfuric acid. On this example design board, we've got a pressure sensor which measures the pressure associated with the height of the fluid column, and thus the level of the liquid. On the reference board, the signal path is processed by some of National's precision ICs. The output of the pressure sensor is handled by several LMP7716 op-amps, and the signal is then converted to digital code using National's ADC122S101. On this user interface that we've developed, we can see a few key parameters. One is the actual level of the liquid in the tank, in this case stated in inches. You can also monitor the input to the data converter in millivolts, as well as the digital code output of the converter. For this demonstration, the control board monitors the level of the liquid in the cylinder, and as we drain the liquid from the tube, the board will activate a pump to refill the tube. When the liquid reaches a maximum level, the pump is shut off and draining process begins again. So there you see how National Semiconductor completes the critical signal path in a sensor-based solution. This sort of application and reference board is exactly the type of solution that can be designed so easily using the WEBENCH Sensor Designer tool. And you can see that the tool offers you both ease of use as well as intelligent design capability. It's just part of National's overall ease of use tool set, along with WEBENCH tools for LEDs, power, signal path design, audio, amplifiers, and active filters. You can experience just how easy it is to use these tools by going to national.com/webbench. There are also other tools and application notes available among the links in this newsletter. And of course, be sure to check out my own personal blog at national.com/energyczar. That's all for this edition of News at National. Thanks for watching. We'll see you again next time.